Hi, today I will be doing an experiment for the removal of a contaminant gas, which is hydrogen sulfide. Usually, hydrogen sulfide, the sources of this comes from sewer gas, stink damp, swamp gas, and manure gases like that. I will be using Solidworks to experiment and do an analysis regarding this. Now I will open Solidworks. As you see in my project, there's this room. As you see, there are the dimensions of the room, and there's a window, there's an exhaust fan, and a window where it's an outlet where the contaminant will go out, like that. And as you see, this is the contaminant. It's a solid object. See, because I need this as an initial condition. And usually, when using flow simulations, this one as an initial condition, using tracer study, you need to make this disabled component, and I will show you. You will need to go to the components control, and then you need to disable this one, the contaminant, the solid box inside the toilet, the one that I'm using as an initial condition. You need to disable this so that you can use this. As you can see, my project setup is this. In as the analysis type, it's an internal with exclude cavities. This one, check, and I use also gravity, at then y direction, negative y, and my fluids is just air. I'm just using air. The wall conditions is an adiabatic wall, and for the initial condition, actually I didn't touch anything here. I only changed this temperature to 27 degrees. And you can also go there in the calculations control option, and you will need to make this as a physical time for the convergence, since this is a transient study, and then make you enable this periodic saving and make it everyone to record as everyone. And then I also included this tracer study, but you need to solve the main you need to solve the main study here first before you can solve this tracer study. And as you can see, I will load now. I will load now the time moment. I will load at 2 seconds time, and as you can see, I also made a cut plot with the mass fraction of this hydrogen sulfide. As you see, it is very high initially at the start of 2 seconds. You see, it's very high. The contaminant is high. And then it's also better that you change this level to the maximum, like 255. It's better that way. And you also go to the appearance and enable this plot minimum and maximum for at least you will know the minimum and maximum. And then, and as you can see, if I go load time moment at the end of the time, which is 40 seconds, you will see that the amount of H2S or hydrogen sulfide is very low. As you can see, it's very low. If we will use a probe, it's very low. You see, there's almost non-existing H2S. And as you see, the H2S, the contaminant H2S, I put in mass fraction of 1, the value, and I used the solid inside as an initial condition, as you see. And you can also use the summary in the tracer study. This will give you a hint for your system, for the effectiveness. For the this one means CRE means for contaminant removal effectiveness of H2S. 0 with the value of 0 means that your system is perfect, and with the value of 1 means that your system is good. Greater than 1, it means that your system is even better, and less than 1, your system is not good. That is all what it's mean. And as you can see, after 40 seconds, the The contaminant is almost to zero. This one is the exhaust fan, and I'm using a window, open window, and an exhaust fan. And this one is also good. Thank you for watching.